Okay, we're live now. Hello, everyone. Welcome to Kyverno Office Hour. Today we have the demonstration from Mariam, who's gonna showcase to generate the validating admission policies from Kyverno policy. And with that, let me quickly hand off to Mariam. You can take over.
Okay. Let me share my screen. Can you see it now?
Yes.
Okay, that's great. So in this session, we will talk about how to write cell expressions in Kyverno policies and how to use these policies to generate validating admission policies. So first of all, what is cell expression? Cell is a powerful language created by Google, and it is used to evaluate expressions. With cell, you have the ability to perform logical and mathematical operations and even filter data, etc. Cell was first introduced in Kubernetes for the validation rules for the custom resource definitions, and it's now used by Kubernetes validating admission policies. Before digging into Kubernetes validating admission policies and what is it and so on, we can start by creating Kyverno policies that use cell expressions. And by the way, if you want to know more about the language and its grammar rules and so on, you can check this link as well as this documentation from Kubernetes. Okay, with that said, we can start creating Kyverno policies using cell expressions. So our first example is about a policy that is used to disallow host path. So first of all, this policy matches pods, and here under the validate rules we can specify our cell expressions in the cell field, as you see. Okay, how to write the cell expression? For example, in this example, this policy aims to reject all resources that have a host path. So first of all, we are checking if am I audible?
Yes, we can hear you.
So first of all, we are checking if the volumes exist or not. And if it does exist, then we are looping through all volumes. And for each volume, we are checking if there is a host path defined or not. So if there is a host path defined, then the whole expression is evaluated to false. And therefore, the admission controller will reject the incoming resource. If the expression is evaluated to true, this means that the resource doesn't violate the policy, and the admission controller will accept the request, and therefore the resource is the resource will be successfully created. Okay, so first of all, let us apply this policy. Okay, we can take a closer look on this policy. Okay, as you see, although this policy matches pods, it's also there are also auto-generated rules that will match deployments, daemon sets, jobs, and all other pod controllers. So actually, this policy will be applied to all Kubernetes pod controllers. And this is due to the auto-generated rules. Okay. And then we have two resources, one of which is a bad resource that violates the policy. So, for example, this resource uses host path, which violates the policy. And if we try to create it, we will see that the admission controller actually will reject the creation of this resource. So let me apply it. Okay, as you see here that there is an error creating this pod. Why? Because the admission webhook actually denied this request because of the disallow host path policy. And as you see here in the message, it says that host path volumes are forbidden. Okay, so this is what we expect. There is also another resource where we are specifying volumes, but we don't specify host path, we specify empty dir instead. So actually this resource will be successfully created because it doesn't violate the policy. Yeah, as you see here, there is, it's successfully created. Actually, we can, describe the policy. You will see from there the events that were generated. As you see here, we have one event for the bad pod, which is a policy violation. The pod was blocked, so there is a triggering event for this pod. And we have another event which tells us like, there is a pod that were successfully created, and it doesn't violate the policy. Okay, that's great. Okay. This is how we write cell expressions in the policy. We have another example for cell expressions. We can combine preconditions with cell expressions. And what is preconditions? So first of all, whenever a resource is created, this resource, first of all, when we create a cluster policy or a Kyverno policy in general, we specify the match block that we are telling the controller that whenever a new resource is created, then we will gonna evaluate this pod against the policy. Okay. In some cases, we need, like filter, we need to filter this more. So, for example, we can specify that this policy will match all pods, but not all of them. Actually, it will match pods that have a specific name. In this case, for example, Nginx pod. So whenever a new pod is created, this pod must match both, must match this condition. And if this condition is evaluated to true and the pod has a name of Nginx pod, then this policy will be applied to the resource. Otherwise, it will not be applied, and the resource will be created as normally because there is no actual policy applied on it. Okay, so I have two resources for that. For example, we have a pod that is called Nginx pod, and it actually violates the cell expression. I forgot to mention that this this policy actually restricts the port range to from 5,000 to 6,000. So the cell expression says that for each, we will looping through all containers, and for each container we are gonna check if the ports is defined or not, and if it does define, then we are gonna loop through all the ports. Okay, as you see here, through all the ports, and for each port, we are checking if the host port is defined or not, and if the host port is defined, then we are gonna check its value, and this value must be between 5,000 and 6,000. Okay, so so this is the whole expression. And for every new pod created, we are gonna check its name first. If its name is called Nginx pod, then we are gonna apply this policy to it, which means that we are gonna evaluate the cell expression. And depending on the evaluation of this expression, the pod will be either created or rejected. Yeah, so this pod actually is called Nginx pod, and as you see here, the host port is set to 80, which is not in the range specified in the policy. So this means that this pod will violate the policy, and it's expected that the admission controller will reject its creation. Okay. The other pod is called busy box pod. As you see, this is it doesn't match the condition. It doesn't match the preconditions specified in the Kyverno policy. So the policy will not be applied to this resource at all, and it will be successfully created, although the host port is set to 80. But yeah, as I said before, the policy will not be applied to this resource because it doesn't match the cell preconditions we specified in the Kyverno policy. Okay, so let's see this. We can create the policy first. Okay. As you see here, the policy is successfully created. We can try to apply the bad pod. Okay. Yeah, as expected, the admission webhook rejected the request because of the disallow host port range policy. And this is because the policy is applied to it and the host port is set to 80, but it must be between this range. Let's try creating the other one. Yeah, you will see here that the busy box pod is successfully created as we expect. Okay, this is for the second example. Another feature is the parameter resources. We have an example about using parameter resources with cell expression. So first of all, what is parameter resources? Parameter resources allow us to write a configuration separated from the policy definition. Okay, so let's say, for example, we need to check the deployment replica. The easiest solution is to write a cell expression like this. Here we are telling that, I forgot to mention that object actually refers to the newly created resource. So here, for example, this policy matches deployment, and for every new deployment, object here refers to the newly created deployments. Okay, so this cell expression is about checking the deployment.specification.replica is less than or equal to 3. Okay, it is simple as that. Okay, but what if we have a more complex configuration? Okay, it's not a good practice to adding all these configurations in the policy. So that's what parameter resources solve. Okay. So through parameter resources, you can, for example, create a custom resource definition, which will behave as your parameter resource. And here, for example, we have a replica limit, which is a custom resource definition, and it has a field called max replica. Okay, is set to 3. And actually, we can have we can have actually more of configurations, but yeah, we are taking a simpler approach to illustrate what parameter resources are. So after we created this custom resource definition, and which has the max replica field, and it is set to 3, we can simply use the params the params keyword. The params keyword actually refer to our replica limit. So yeah, the params keyword actually refer to our replica limit, and this is how the params keyword refer to replica limit. This is how we can do it. We are actually we can do it by specifying the param kind and the param reference. The param kind actually defines the group version kind of the resource, and the parameter reference actually ties the param kind to a specific resource. Okay, so for example, here the param kind, we are specifying the API version, the kind is replica limit, and in the param references we are specifying the name, which is replica limit. Yeah, the same name as the resource we have just created. And here we are specifying the action when the parameter resource is not found. Okay. Yeah, that's it for the parameter resources. We can see the custom resource definition here. For example, I created a custom resource definition, and here is the main fields: the API version, kind, metadata, max replica. As I said before, we can write more configurations in this custom resource definition, and we can invoke all these fields in the policy by using the params keyword. Okay. Yeah, so let's start by creating this policy. I have already the custom resource definition and the replica limit applied to the cluster. So we will start by applying this policy. Okay, so the policy is successfully created, and we have two resources, one of which does violate the policy. Here, for example, we have a deployment fail. It has a replica of 4, which violates this expression because params.maxReplica is equal to 3. Okay, we have another resource that doesn't violate the policy because its replica is equal to 2, and as expected, it should be successfully created. So let's apply these two resources. As expected, the admission webhook rejected its creation because of the check deployment replica policy. And here is the message. If we try to apply the other resource, it will be successfully created. Okay, actually there were okay, this is weird. Yeah, I can delete these spots for now. Oh, sorry. This deployment is created in the test.ns namespace. So yeah, it were already created there. So maybe we can delete it. Okay, so if we try to, create the resource, you will see that it is successfully created. Okay. Yeah, that's it for Kyverno policies with with cell expressions. The first thing is that we can actually generate validating admission policies to from these Kyverno policies. So validating admission policies is created by Kyverno, so it is somehow handled by the API server, and we can generate it from Kyverno policies. So for example, here is a validating admission policy that check the deployment replica as you see here, it matches deployments, and here is the cell expressions. And actually, writing a validating admission policy alone is not enough. You should create a validating admission policy binding as well, because this resource provides scoping to the policy. And yeah, you can define the policy that you want this binding be applied to, and you can define the validation actions. The validation actions simply tell the API server what will be the action if if the resource, the incoming resource violates the policy. Should the API server reject its creation, or should it allow, or it should allow the creation of this resource and maybe display a warning or so. So yeah, this is about the validation actions. So let's start. Let's start generating validating admission policy. First of all, there is a flag. Let me show you. Sorry. So in the admission controller, there is a flag specific to whether generating VAPs is allowed or not. So if you need to generate validating admission policies from Kyverno policies, you need to set this flag, because it is set to false by default. So let's edit this deployment. Yeah, the best way to do so is to modify this value in the values.yaml if you deployed Kyverno using Helm. But for the sake of this demo, I will just modify the admission controller deployment instead. Okay, so let's check if we are actually having, as you see, 3 cluster policies, and it is supposed to have the validating admission policy generated. Okay, this is weird. Let me check. Okay, the VAPs is successfully generated. The VAPs is the VAP flag. Okay, so as you see here, the validating admission policy are successfully generated. Maybe it needs some time to do so. You can check the binding as well. As I said before, validating admission policy alone is not enough. We need to create its binding as well. So as you see here, we have the 3 validating admission policies. For the 3 Kyverno policies, we have just we have created before, and we have their corresponding bindings. Okay, let us take a quick a closer look on the validating admission policy. Maybe it's allow host path, for example. As you see here, that here is the validating admission policy. It's managed by Kyverno, and it has the same name of the Kyverno policy, and the owner references is the cluster policy, which was responsible for generating this validating admission policy. And as you see here, we are actually matching pods, and here is the cell expression. Okay, so we can have a quick look on its binding as well. Sorry. Okay, as you see here, here is its binding, and it's managed by Kyverno, and the owner references is the same. And here is the policy name, and the validation action is deny. It's deny because when we try to, create this Kyverno policy, we specify that the validation failure action is set to enforce. So its corresponding value is deny for validating emission policies. Okay, so let's, for example, first of all, let's see what deployments we have. Okay, that's great. We don't have deployments for pods. Let me just delete this pods so that we can create new pods and see the validating emission policy in action. Okay. So, for example, if we try to apply this, maybe this resource, it is expected that the validating emission policy will reject the creation of this resource. Yeah, it's not from the admission controller, it's from the API server. The API server rejected the creation of the resource as a result of applying validating emission policy on it. If we are gonna apply the Kyverno policy, the rejection or the allow of the creation of this resource will be handled by Kyverno admission controller. So there is a difference between both of them. Okay, as you see here, that this resource got rejected because of the validating emission policy. The API server actually denied this request, and here is the message that we were specifying. Here in the Kyverno policy, which already exist in validating emission policy as well. Okay. If we try to create the good one, yeah, you will see the good resource is actually created, okay, because the API server allows its creation. Okay, this is about the validating emission policy. We can, for example, try this one as well. If you want to check that, we can first of all get all the admission, get all the validating emission policies. Okay, we can have a closer look on, disallowing host port range. Sorry. As you see here, it's managed by Kyverno, and the owner references is the Kyverno policy, which was responsible for generating this validating emission policy. And as you see here, here is the cell preconditions. It is under match conditions, and here is the cell expressions that will be evaluated if the resource meets this requirement. Okay, so if we try to, apply this policy, it is expected that this resource will be rejected from the API server. Sorry. Okay, as you see here, the validating emission policy is applied and the API server denied the request. Okay, so this is about generating validating emission policy from Kyverno policy. It is super helpful and easy for those who are familiar with the Kyverno policies. Okay. Next is we can generate. We actually can generate reports for this validating emission policy. Let's say we have existing resources. For example,
Mariam, sorry for the interruption. I have a question for the VAP generation.
Yeah,
so
sure.
if you can take that, or yeah. So you said the VAPs are generated from Kyverno policies, and if there's any change in the Kyverno policy itself, will Kyverno sync those changes down to the generated VAPs, or how would that work?
Yeah, for example, if we, for example, if we changed any changes in the cluster policy will lead to the same changes in validating and mention policy. For example, if we removed this policy, then the corresponding VAP and its binding will be removed as well. So, for example, we can change this message to anything. Okay, so let me apply this Kyverno policy. Okay. The change should be reflected in validating and mission policy. Let me. Okay, as you see here, the message is also modified. Okay, for example, if user tries to, modify the message from validating and mission policy, then, the controller will try to remove this change and try to resync the validating and mission policy with the Kyverno policy. We can, for example, edit the validating and mission policy. Okay, we can we can, for example, modify the message as that. Okay, if we try to get the validating and mission policy, you will see that the message, whatever changes done by user, it will be reverted. Okay, so the controller is responsible for syncing the validating and mission policy with Kyverno policy, no matter what user have changed it or removed it. If for example I deleted the validating and mission policy, it is supposed to be recreated. Okay. Okay, as you see here, the disallow host path is created 6 seconds ago. Any questions?
No, that's awesome. Thanks.
Great. Okay, so then the next thing is about generating reports for validating and mission policies. So actually we can have a lot of resources, and then we can create a validating and mission policy after that. And maybe we need the existing resources, maybe some of the existing resources violate this newly created policy, and there will be some use case that we need reports to see which resources pass the policy and which resources violates the policy. So first of all, let me clean up the policies we have just created. Okay. The bad pod is not created in the first place, so it's complaining about that. Okay. Okay, let's say, for example, we have let's stick with the disallow host path because it is the simplest one. Let's say, for example, we will apply this bad pod and we will apply the good pod, okay, before applying the policy itself. So okay. we have applied 2 pods now, and the second step is to create the Kyverno policy, and it is expected that the validating admission policy will be created from this Kyverno policy. But after doing so, we need to set the flag for generating reports for validating admission policy in the reports controller. So if we try to get the reports controller, you will see, you will see that we have a flag for generating reports specifically for validating admission policy, and by default it is set to false. We can modify that and try to set this flag to true instead. Okay, that's great. So now we have this flag set. It's supposed that whenever a new policy is created, there will be a report for the existing resources after applying the new policy on them. And also, if we have newly created resources, there will be a report for them as well. So let's start by applying the Kyverno policy. Okay. By the way, you can check the status of the Kyverno policy to see if a corresponding validating admission policy is generated or not. Okay, so let's check that quickly. Okay, as you see here, we have validating admission policy and it is successfully generated. Okay, so yeah, we are all set up. Let's see if there is a policy reports created. Okay, as you see here, there are 2 reports. The first report indicates a pass result, and the second report indicates a failure. We can check the first one, for example. It is expected that this report is for the good pod because it actually doesn't violate the resource and it should be passed. Okay, as you see here, here is our policy report and it's managed by Kyverno. The owner references is the pod. As you see here, here is the name of the policy, disallow host path, and it comes from the validating admission policy. And the scope is the resource that this report is generated for. And here in the summary, you see that it indicates, the resource doesn't violate the policy, and it is, it has a pass result. Okay, we can check the other report as well. Okay. Yeah, for this report, it is for the bad pod, and as you see here, we have a message that the host path is not allowed, and it comes from the validating admission policy. And yeah, here is the scope, and it actually encounters a fail result. Okay, we can create a new, we can create a new pod for that, for example. Sorry, let's change its name. Yeah, so this pod doesn't specify any volumes at all, so it's expected to be successfully created. Okay, so let's apply this one. Okay, so this pod is successfully created, and let's check the policy reports. Okay, I don't know, maybe it takes some time. No, it's a little bit weird because the policy it assumes that I am assuming that a policy report will be generated. No, it's not a background scan report. It's okay. Yeah, here is it. We have a policy report we just created 1 second ago, and it has a pass result, so we can take a closer look at it. 6, 8, 7. Yeah, you see here that of course it's managed by Kyverno, and the owner references here from the new pod. It's actually this report is generated for the new pod, and here is the policy that was applied, the validating admission policy, and the result pass. That's it for generating reports. Is there any questions so far?
No, not really related to the demo. By the way, great demo, Mariam. So the question I have is around how can we test the VAPs or the cell Kyverno policies? I know Shalawar and Frank has been working on supporting the cell policies for the playground. So I was wondering if the generation of the VAPs are fully supported by the playground, or we can only process the Kyverno cell policies at this point.
Actually, there is for the playground we have the users can write validating admission policy, and the playground can process that,
including the VAP generation as well.
I'm not sure for the VAP generation, but user can write validating admission policy in Kyverno playground, and it will be processed.
Okay, it would be awesome if we allow users to turn on the VAP generation on the admission controller as well as reporting, and have the playground support the VAP generation in some ways.
It would be a great idea. Yeah,
Yeah,
so in that case, the Kyverno playground will generate validating admission policy, and it then can process it, right?
Yeah, I believe so. But I'm not sure how the response is processed, because I don't know if it's listening, watching the Kyverno response or the response from the API server. I guess the API server should be it.
Yeah.
Okay, thank you. Can you please also upload your demo manifest to the repo, like the Kyverno office hour repo?
Yeah,
so that
sure.
We can try it out.
Yeah, sure. I will upload it tonight.
Thank you. All right, let's see if we have any other questions from Anushka, Vishal.
No, nothing from me. Great demo, Mariam, by the way.
Yeah, feel free to reach out if you have any questions regarding cell expressions or validating admission policies.
Yeah, like Mariam mentioned, all these features will be supported in Kyverno 1.11, and we just cut RC1 today, and the official release will be out soon.
Yeah. Also, we have Kyverno policies that use cell expressions for pod security standards in the policies repo. It will be merged soon, so yeah, it will be available soon.
Awesome. Thank you, everyone. I'll see you next month. Take care. Bye.
Bye.